All right, section 6.4 now. We're going to talk about elimination using multiplication. So previously we did elimination with addition and subtraction to solve systems, and now we're going to use elimination with multiplication to solve systems and also look at some examples of how systems can be applied to solve real world problems. And that's our vocab for today. So this table shows the number of cars at Scott's Auto Repair for each type of service. The manager has allotted 1,110 minutes for body work and 570 minutes for engine work. The system 3R plus 4M equals 1,110 and 2R plus 2M equals 570 can be used to find the average time for each service. So that's a system of equations, and you could see that elimination just using addition and subtraction isn't going to work because neither the R's or the M's have the same coefficient or opposite coefficients. They have different numbers in front. And if you solve for R or solve for M, you might end up with some crazy fractions that might make it difficult. And also, if you try to graph it, that also might be difficult to find the intersection point. So, how we use multiplication to solve a system by elimination is first multiply at least one equation by a constant to get two equations that contain opposite terms. Second, add the equations eliminating one variable, then solve the equation. And then substitute the value from step 2 into one of the equations and solve for the other variable. And then write your solution as an ordered pair. And like before, I know just going through the steps, it might be kind of fuzzy and like, oh, what are you talking about? So we're going to go through some examples on how to do it. Okay, so notice again here in this situation, if I want to solve this system using elimination, neither of the variables, I mean, I have my columns aligned, so I got that going on for me, but neither of my variables have the same coefficient or opposite coefficients. All right, so step 1 is I have to multiply by something to get one of the coefficients to be opposite. So if you notice, the 3 and the 6, usually if one coefficient is a multiple of another, that's a very easy thing to fix. So if I could get this 3 to be a negative 6 if I multiply this whole equation by negative 2. So it's kind of like I did this, negative 2 times that whole equation, and then I did that. And the reason that's allowed is because, remember, way back when we started solving equations, you were, as long as you did the same thing to both sides of the equation still was true. So as long as I multiply both sides of this equation by negative 2, it's still the same equation, or it's still balanced, I should say. Okay. So just be careful with the signs. It becomes negative 4x minus 6y equals a positive 10. And then I can add those, and the y's would cancel out because they have opposite coefficients. And 5 minus 4 is 1x, or just x, and negative 8 plus 10 is 2. So I get the y value eliminated, and also I got lucky because x is already by itself now. Okay, so step 3 is to then substitute that answer into one of the equations, and I just picked, you have to do one of the original equations, and I just picked the second one. So I plug in 2 for x, simplify, subtract 4 from both sides, divide by 3, and you get y equals negative 3. And so the solution as an ordered pair is 2 comma negative 3. All right, here's a couple for you to try. Go ahead and pause the video. All right, we're back. So number 1, A, I'm going to multiply the second equation by negative 3 to get the x coefficients to be opposite. So that's going to be negative 6x plus 21y equals 57. Right? 3 times 19 is 57. Okay. So then we add the y's, and you would get 19y. Oops, I see what I did. I multiplied by 3. Negative 3. You got to multiply by negative 2. My bad. So you would have 6x minus 2y equals 10, and negative 6x plus 14y equals 38. So those cancel. I get 12y equals 48. Divide both sides by 12, and you get y equals 4. Plug that back into the second equation. I'm going to do the first one in this case, and you get 6x minus 2 times 4 equals 10. So 6x minus 8 equals 10. Add 8, so you have 6x equals 18. Divide by 6, you get x equals 3. So your ordered pair is 3, 4 for that one. Okay. The second one, I would multiply the second equation by negative 3. So you have 9r plus q. You know what? Let's do something different. Let's multiply the first equation by negative 2 to get the q's to cancel. So I'd have negative 18r minus 2q equals negative 26. And the other equation would be 3r plus 2q equals negative 4. And when you add those, the two q's cancel, and I get negative 15r equals negative 30. So divide both sides by the negative 15, and you get r equals 2. Then you can plug that back into one of the original equations. So I'm going to plug it into the first one. So it's 9 times 2 plus q equals 13. So 18 plus q equals 13. So q equals negative 5. And my ordered pair in alphabetical order, r does not come first. It can be negative 5, 2. Okie dokie. Pretty cool stuff going on there. All right, sometimes you have to multiply each equation by a different number in order to solve the system. In other words, one of the coefficients is not a multiple of the other ones. So a situation like this might come up. 4 is not a multiple of 3, and 2 is not a multiple of 3 either. So I can't just multiply one of the equations by one number and get one of the coefficients to be opposite. So I have to kind of adjust both of the equation. So when that happens, you can multiply each equation by the coefficient of the other one and just make sure one of them is opposite when you finish. So in other words, if I have 4 and 3 here, you can multiply to get it to be the least common multiple of 4 and 3, which is 12. So the first equation, I'd have to multiply everything by 3 to make it 12. The second equation, I have to multiply everything by 4, but I want it to be opposite, so I multiply by negative 4 so that the 12s are opposite. Okay, so we multiply the first equation by 3, the second equation by negative 4. We get this. I add those together, the x's cancel. Then you get negative 6y equals negative 12. Divide both sides by negative 6, you get y equals 2. Plug that into either of the equations that you originally started with. We're going to pick the second one, so substitute 2 in for y. Simplify, subtract 6, divide by 3, and you get x equals 1. So the solution is 1, 2. Another way to do it, see there's multiple ways to do these, is to get the y coefficients to cancel. So in this case, the least common multiple of 2 and 3 is 6. So I want one of them to come out to be 6 and the other one to be negative 6. So I multiply the first equation by 3, second equation by negative 2. Add those together, and this time the y's cancel. So I get 6x equals 6. Divide both sides by 6, you get x equals 1. Then you substitute that into either of the equations. I picked the second one, so plug 1 in for x. So subtract 3, divide by 3, and you get y equals 2. which is the same exact answer I got in method 1 when I got the x's to cancel, which should be the case because it's the same exact problem. I should get the same exact answer doing it 2 different ways. Okay, so here's a couple for you to try. Now, you don't have to do both methods whenever you solve them. You can just pick one. You can, like, for 2b or 2a, for example, you can either pick, get rid of the x's or get rid of the y's. You don't have to do it one way and then do it the other way. All right, go ahead and pause the video. All right, we're back. So 2a, I want to do something because notice that the y coefficients already are opposites. So, but one's not a multiple of the other, and neither is that true with the x's. Neither the 5 and 2 are not multiples of each other, and 3 and 5 are not multiples of each other. But the y's are already opposites, so I'm going to multiply those to get the least common multiple of 15. So the first equation, I'm going to multiply by 5, and the second equation, I'm going to multiply by 3. And notice I don't have to multiply either of them by a negative because the signs are already opposites. So that's going to give you 25x minus 15y equals 30. And then you'd have 6x plus 15y equals negative 30. So the y's cancel, and you would get 31x equals, and notice 30 plus negative 30 is 0. And you're allowed to have 0 as one of your answers. So that just means x is 0. Well, I'm going to plug that into the first or second equation. I'll just do the first one. 5 times 0 minus 3y equals 6. So be negative 3y equals 6. Divide both sides by negative 3. Then you get y equals negative 2. So your ordered pair is 0, negative 2. Okay? All right. I'm not going to run all the way through example 2b, but I will tell you that the correct answer is negative 1, 4. So you can check your answer there, whether you eliminated the a's or the b's, doesn't matter. Now, I will say, if you eliminate the a's, some people would multiply the first one by 4 and the second one by negative 6 to get them to be opposites. But the least common multiple of 6 and 4 is not 24, it's actually 12. Now, it doesn't matter if you get it to them both to be 12 and negative 12 or 24 and negative 24. But often it's easier to work with smaller numbers. Okay? And if you eliminated the b's, you'd probably get 6 and negative 6 if you did it that way. All right? Well, that's it for this video. Please stay tuned for the second half of this section, and we'll see you there.